Good afternoon. Welcome to Matric Question Monday. This is episode 4. Last week we looked at question 2 of the Gauteng Department of Education preparatory examination, which was number patterns or series and sequences. And today we are looking at question 3, which is also in that same chapter, but working with sigma notation. So it says given sigma k equals 1 to n tk equals n squared plus 4n. This is question 3, where tk is the general term of a sequence. So I have the general term of a sequence there, which they don't give to me. Just be careful. This is not my general term. This is my general term. The sum of all of the general terms from 1 to term n is going to be n squared plus 4n. So basically, my Sn is n squared plus 4n. My A, my N, my R, I don't know. Right, this is a sequence. I don't know if it's a geometric or arithmetic sequence yet. But then in question 3.1, they want me to say calculate the sum of k from 1 to 250 of tk. Now I can just use my n, you see, is now 250, so I just substitute 250 in there. 4 times 250, and I can take my calculator and just work that out. Right, so I have 250 squared plus 4 times 250, and that gives me 63,500. Right, so the sum of the first 250 terms is 63,500. Right. And then question 3.2 says, calculate term 100. So now I want term 100. Right. So what I'm going to do is start by calculating the sum of 100 terms, which I use this formula for now, n squared plus 4n, where n is 100. This is my sum, right? So this is 100 squared plus 4 times 100. And again, I just use my calculator for that. No need to try and complicate things by trying to work that out yourself. So the sum of the first 100 terms is 10,400. And the sum of the first 99 terms, the reason why I do this is because I want the 100th term. Now, if I take the sum of the first 99 terms and I take the sum of the first 100 terms and I subtract them, then I have, what did I add from sum of 99 to sum of 100? I added the 100th term to get to that. So the sum of the first 99 terms is this. I'm just going to use the formula to calculate the sum. And I'm just putting 99 squared plus 4 times 99 in my calculator, and this gives me 10,197, which means when I added the first 99 terms, I have 10,197, and then if I add the 100th term, I get 10,400, which means that the 100th term is 10,400 minus 10,197, and that is then 10,400, 10,197 is 203. Right, so the 100th term is 203. And then in question 3.3 they say, how many terms of the sequence must be added to give a sum of 1,440? Right, so how many terms must I add to get a sum of 1,440? Okay, now I know my sum is given by the formula n squared plus 4n. And if I make that 1 for 40, I bring the 1 for 40 over. And then you can either factorize this or just use the quadratic formula. I think to go and list all of the factors of this is going to take some time. So I'd rather just use minus b plus or minus the quadratic formula, the square root of b squared minus 4ac 1440 over 2a. A is 1, so 2a. And just put that in my calculator. So I first press the fraction, minus 4 plus root of 4 squared, which is 16, minus 4 times 1 times minus 1440. I'm not even going to put in the minus 1 of the 1 because that just keeps it the same. And then I've got 2 at the bottom, and this gives me n equals 36, or n equals I'm just going to go and make this plus a minus, and I've got minus 40. Right, now I won't have a term number minus 40, so this one is not applicable, or you can just write there NA for not applicable, but then it's term number 36. All right. Okay, so this is question 3 of the Gauteng departmental paper of September 2015. And I just quickly want to do a question which is not in this question paper that I picked up from one of my students during this week. I think it's quite an interesting question, so I thought I'd share this with you guys. It says, use this sum of infinity. Now you know that's for the geometric series that converges. Use this formula to calculate or to write 0.2 repetitive. I can't think of what is this recurring. 0.2 where 2 is recurring as a fraction. Okay, use this formula to write 0.2 recurring as a fraction. Right, so what this is, 0.2 recurring, looks like this, right? Okay, and I know this formula works with sequences and series, so I'm going to try and express 0.222 as a series. Now, I can do this by just writing all of these, like 0.2 plus 0.02 plus 0.002, which will be 2 over 10, plus that one is 2 over 10, and then that one is 2 over 100, plus that one is 2 over 1,000, plus and 1,000, and it will continue like that. Right, which means I've got a if I look at this, term 2 divided by term 1 is 1 over 10. Term 3 divided by term 2 is 1 over 10. So I've got a geometric series where my R is 1 over 10. My A is 2 over 10. And just to confirm that it is a converging geometric series, R should be between minus 1 and 1. Which 1 over 10 it is, I'm fine. And then I can just use this formula, A divided by 1 minus R, 1 minus and R is 1 over 10, equals, and you can use your calculator, but this is 2 over 10 divided by 9 over 10, so times 10 over 9, and that becomes 2 over 9. So that's just an, hey, I like it. That's just an interesting, awesome question that has to do with sequences and series. Right, okay, Matrix, enjoy your week, and please, if you do come across interesting questions, please let me know about them, and I will have a look at them. And good luck for this week. Enjoy your day.